Hi friends, welcome to Guru Maths Theory. Problems we have already covered in this app. All difficult problems are solved. They are useful for CBSE, ICSE and various state boards. Kindly follow those. In this video we will be focusing only on theory of whole numbers. So let's start. Firstly, what are natural numbers? Natural numbers means starting from 1 all the numbers up to infinity. 1, 2, 3, 4 up to infinity. Okay, these are natural numbers. Then what are whole numbers? Whole numbers means starting from 0. Okay, so say this: natural 1, 2, 3. If you add 0 to it, it becomes whole. Then if you add minus numbers to it, it becomes integers. Then if you add the fractions to it, it becomes rational. And the rational is altogether a big ball game actually. And then we have irrational, and these all are called as real numbers. And there is also one more concept called as imaginary numbers. We have already covered this in knowing your numbers. What is predecessor and successor? Here, when you add 1 to any natural number, we get the next number. Why only natural? To whole also. If you add 1 to any whole number, even integer also, if you add 1 to any integer, we get the next number, which is called a successor. Means 12 plus 1 is 13. 13 is a successor of 12. Okay. If we subtract 1 from any number, not natural actually, it's any integer or any one, we get a predecessor of that number. Means 12 minus 1 is 11. So 11 is a predecessor of 12. So here also 12 is a predecessor of 13. So subtract 1 and you get the predecessor. Okay. In natural number there is no predecessor to 1 in natural, but if you count whole numbers, then there is a predecessor to 1 also. If you count integers, there is a predecessor to 0 also. Okay. So whole numbers we have already discussed. Collection of natural numbers including 0. Okay. So starting from 0 it goes on. So natural number line. The number line means what? We draw all these numbers, we draw a straight line and put all these numbers on that line. That is called as a number line. We have covered this in knowing your numbers. Okay, you can follow that. How to find the distance between 2 points? Here, if I have to find the distance between 1 and 5, how will I do? 5 minus 1, that is 4. Go on counting 1, 2, 3 and 4. These gaps we have to count. Okay. So that is the distance between 2 points. The greater number on the number line. Always the greater number will be on the right side and smaller number will be on the left side. Okay. So remember, it comes in exams also. The smaller number will always be on the dash side in the number line, left side on the number line, right? Greater number will always be on the dash side of the number line, right side of the number line. These theories come in the exam also. Now addition on a number line. Suppose if I tell you to add 2 and 5, it's very easy. You'll say 2 plus 5, 7. Okay, but how to show it on the number line? See here, first take 2 and then go on counting 5 gaps, 1, 2, 3, 4 and 5, and you come to 7. So that way it is shown on the number line. Subtraction on the number line, similar way. Suppose if I tell you to subtract say 6 from 10, then what we do? We start with 10 and move to 6 gaps towards the left. See here, important part is, in addition you move towards the right. In subtraction you move towards the left. Why? Because subtraction means we lessen the number, we reduce that number, and reduction is always left and addition is always right. We have just now seen it, greater number and smaller number, right? So always remember, while addition you move to right, while subtraction you move to left. Okay, on a number line. Now multiplication on a number line. If you have to multiply 4 and 3, then start from 0, make 4 jumps using 3 units at a time to the right as you reach to 12. So see here, 0 starting from 0, 4 into 3. See here, it's very easy for you to directly do it, but on the number line you have to imagine that take a jump of 3 and 4 times, because 4 into 3, so you come to 12. So that's how it is shown on the number line. Properties of whole numbers. Now closure property. See here, we have studied these properties earlier also for integers in 2 chapters separately. So you can follow that also. It's quite easy. Closure means what? Two whole numbers are said to be closed if their operation is a whole number. Means what? Suppose if I add 2 plus 5, so it is 7. So 2 is also whole number, 5 is also whole number, and 7 is also whole number. So their answer should be again the same set. Means if we are adding whole numbers, then the answer should be whole number. That's what is the meaning of closure. So addition, addition means whole numbers are closed under addition as their sum is a whole number. If we add two whole numbers, their sum is a whole number. So yes. Subtraction, whole numbers are not closed under subtraction as the difference is not always a whole number. Okay. Why not? See here, 9 minus 2, 7 whole number, it's okay. But 2 minus 9 is minus 7. So is this a whole number? No. So that's why they are not closed. Multiplication, yes, they are closed. Whole numbers are always closed under multiplication as the product is a whole number. You multiply any two whole numbers, the product will be a whole number. Means 0, even if you add 0 also, 0 into 5 is 0. So 0 is a whole number. Division, no. Why? Because whole numbers are not closed under division, because as the result is not always a whole number. Means what? 5 divided by 1 is 5. That's okay, whole number. So it is closed in this operation. But 5 divided by 2 is 2.5. Is it a whole number? No. So that's why it's not closed under closed under division. So always remember, closure means what? If you do that operation, the answer should be from the same set only. If you do the operations on whole numbers, the answer should be a whole number. Next, commutative property. Two whole numbers are said to be commutative if their result remains the same even if we swap the position of the whole numbers. Means even if we swap the position means what? It means suppose if you add, see this, 2 plus 5 is 7 and 5 plus 2 is also 7. So that's why it is yes. Now is this possible in subtraction? No. Why? Because 9 minus 2 is 7, but 2 minus 9 is not 7, it is minus 7. That's why in this case it is not closed. So commutative property, it means, is not applicable for subtraction. See this, subtraction is not commutative for whole numbers as the difference may be different if we interchange the position of the numbers. Right? So it is not commutative for subtraction. But if this would have been for integers, then it would have been commutative. Means 9 minus 2 integer, 2 minus 9 is again an integer but not a whole number. So remember, what are we studying? That's important. If we are studying whole numbers, then subtraction is not commutative. Multiplication. Multiplication is commutative for whole numbers as the product remains the same even if we interchange the position of the numbers. Okay. So even if we interchange the position, so what does it mean? 9 into 5 is 45, 5 into 9 is 45. So it's the same. In subtraction of integers also, I have told you that it is commutative in integers. So it's not. Just now I got the clarification from my side. Means it's not commutative for integers also, because 9 minus 2 is 7 and 2 minus 9 is minus 7. It's not 7. Right? So it's not commutative for subtraction. Division, yes. The division is not commutative for whole numbers as the result may be different if we interchange the position. Means 5 divided by 1 is 5 and 1 divided by 5 is not 5. It is something separate, 0.2. So answers are different. That's why divisions are not commutative for whole numbers. In fact, for any numbers. Associative property. Two whole numbers are said to be associative if the result remains the same even if we change the grouping of the numbers. Grouping means what? Say this, 3 plus 2 plus 5 in one bracket and 3 plus 2 in one bracket and 5. So is the addition of both of these same? Yes. 3 plus 7 and here 5 plus 5. Answer is same. So that's why it is associative. Addition is associative. Now subtraction. Let's see. Subtraction is not associative for whole numbers as the difference may change if we change the grouping. How? Let's see. 8 minus 10 minus 2. Okay. 10 minus 2 in the bracket. Now next what we do? We change the bracket. It becomes 8 minus 10 in one bracket and then minus 2. Then what is the answer? 8 minus 8 over here, and here 8 minus 10 is minus 2, minus 2 minus 2 over here. So here it becomes 0, here it becomes minus 4. So answers are not same. That's why subtraction is not associative. Now multiplication. Multiplication is associative. Why? Because even if you change the brackets, the answer is the same. You can try it yourself now. It's easy. Division. Division is not associative. Why? Because even if you change the numbers, means the position of the numbers, then if you change the grouping of the numbers, then the answers become different. 24 upon 3 and 4 upon 2. Both are different. How? Say this. 2 and 4, if you do it, 24 you do it over here, and so division is not associative for whole numbers. Next, distributivity of multiplication over addition. It means what? Suppose here, if you add y plus z and then subtract and multiply it with x, then what will be the answer? Here it becomes like this: x into y plus x into z, right? xy plus xz. See, these things you will understand better once you solve the examples. These examples are solved in this maths app, Yuaguru maths app. You can follow that, download it and try it yourself. So what happens? You will understand it better. Practice makes you perfect. Okay, let's move on. Next is, see this example, 15 into 45. So 15 into 45 equals to 15 into 40 plus 5. So 15 into 40 plus 15 into 5. So here 15 into 40 plus 15 into 5. So answer comes as the same. So 45 into 15 is 675, and even if you do this operation, it's 675. That's why distributivity of multiplication over addition is possible. Then identity of addition. Identity means what? We have studied this in our earlier chapters also. If we add 0 to any whole number, the result will be the same number only. Means the answer should not change. So a plus 0 is 0 plus a is a. So 0 is the additive identity for whole numbers. 0 is the additive. Remember, additive. There is also multiplicative identity. We'll see that now. See this practical. 2 mangoes or apples plus 0 apples equals to 2. So additive identity is this 0. Similarly for multiplication, multiplicative identity means answer should not change. So a into 1 equals to a, and 1 into a equals to a. So 1 is the multiplicative identity. Remember this. Okay, remember these two numbers correctly. Additive 0, multiplicative 1. Okay. Now study of patterns. Patterns are used for easy verbal calculations to understand the numbers better. Right? Means it should be easy. It should be available on your fingertips. So we can arrange the dots in the elementary shapes like triangles, squares, rectangles, etc. These are called as patterns. So see this. These examples you can see this. 1, 2, 3, 4, 5 shown. Then 6 is shown like this as a rectangle. 12 is a rectangle. And then we can arrange some other numbers using the squares. See this 9, 16, which are perfect squares. Those are arranged over here. Then using triangle, then 3, then 6, and this 9. Sorry, not 9. 4 plus this is 3, 7 plus 3, 10. Okay. So 3, 6, 10. Okay. So why are we arranging them in patterns? See, what happens is, for doing verbal calculations, we need to arrange them in patterns. It becomes easier to do through verbal through pattern system. Like for example, 123 plus 9. You'll say it's so easy. It's 132. But follow the pattern. 123 plus 9, make it 10 minus 1. So 123 plus 10 is easier. 133. 133 minus 1 is 132. Now you'll say it's quite easy. Why do I do it this way? But look at the difficult numbers like 123 plus 99. Now it's difficult. So 123 plus 100 minus 1. So 123 plus 100 is 223. 223 minus 1 is 222. Now it becomes easier. Similarly this multiplication. 83 into 9. So 83 into 10 minus 1. So it becomes 83 into 10, 830 minus 83, 747. Right? 83 into 99. 83 into 100 minus 1. So 83 into 100 minus 83, 8217. So That was a theory on whole numbers. We already have solved problems in this app, Yuvaguru Maths Olympiad app. Those are useful for CBSE, ICSE and state board, everyone, whoever is doing maths. So you can download this Yuvaguru Maths Olympiad app from Play Store to get its videos, tests, question banks with explanations. It covers problems as well as theory. You can get 500 plus questions with explanations and case studies on your PC. It's a separate paid version. Follow us on Facebook on this link. WhatsApp us on this number for any query related to purchases. Keep studying, keep watching. Thanks.